value, which is go to the question that you guys have earlier in the beginning of the class. All right, if you don't have question, here come your expected value, right? Your expected value is this, which is, again, suppose that they say a 20 years old can purchase a 1 year's life insurance policy for $10,000 at the cost of $100. In the past history indicate that the probability of a person die at the age of 25 is 0.0015. Determine the commonly expected value, expected gain, or expected loss, right? So look at this thing here. If you remember, to find the expected value, this is what they ask you to do, is to find the expected value. For me, I actually got to do this, or to make this table, right? What is this table? Which is, again, the table of the amount that you gain and the amount that you lose or loss, right? Your gain and your loss. So this is the three things that we need. We need the amount, which is everybody see that the company will gain $100 for every policy that they sell out, that they sold, they gain $100. The company, right? And the amount that they lose, for instance, if I buy this policy and I were to die at the age of 25, everybody see that the company pay out $10,000, but they not really pay out $10,000. Why? Because they took my $100 and they give me $10,000, which is they only actually pay out $9,900, right? Because again, they basically give me $10,000, but 100 of them, well, they don't give me, they give my family because I'm dead, right? But again, the $100 was my money, right? So the company not really lose $10,000, they only lose $9,900, right? So that's what you have to ask yourself is, what is the net gain or net loss, right? If they gain $100. If they lose, the net loss here is $9,900, right? And then look at this thing here. What is the probability of them losing $9,900? The probability of me dying at the age of 25 is 0.0015, which is, again, if that is 0.0015, and again, that's very small, right? That's all the chances that me dying. And this is a chance, if I were to die, they have to lose this, right? And now you probably say, wait a minute, Mr. Tran, where is 0.9985 come from, right? So think about this thing here. Just go to connect to chapter 11. If we know that a small group of item is 0.0015, what is the leftover probability? Well, how do I find the leftover? Which is I have to take 1 minus this item. Or if I know that the total area under the curve is 1, and I know that the portion is 0.005, I have to take 1 minus the 0.0015, which is, that's where I have the probability. And once we have this thing here, all we need to do is we need to multiply the 100 times the probability. This is 9,900. Small typo is 9,900, not 990. Again, once you have this thing here, this is what you have is you take the two number, 99.85 minus 14.85, which is, if you subtract this thing here, everybody see that is plus 85. Plus 85 meaning the company expect to gain $85 for every $100 that they get. Okay, so again, this is what we did in terms of the meeting we have, in terms of we construct the chart, right? Whoever did the Alex portion, whoever did the homework or the test on the Alex portion, Alex do a little bit different from me. Alex say, well, instead of deduct the amount, this is what Alex does. And I don't know which method you guys clicking in, but let me show you what Alex do, and then see which method you like better. Okay, so what Alex does is they say, well, instead of deduct what we have, let's just attack what they give us. Do you agree that the company will lose $10,000 And what is the probability of them losing $10,000? The probability of them losing $10,000 is this, which is, again, this is the probability they will lose $10,000. And what is the probability of they losing $10,000? Well, the probability of they losing $10,000 is 0.0015. Why? Because if I die, the probability of me dying is 0.0015. And if I die, they will lose $10,000, right? So this is what Alex does, is they say, well, all you need to do is take the amount, either gain or loss, multiply to that probability. And whatever they don't give you the probability, if you gain, you add them. If you lost, you subtract them. So in this case, instead of deduct from 10,000, deduct to 9,900 in terms of deduct in the beginning, they just go straight and apply this item here, which is they tell you that same idea that we had before, it's just that I deduct the item, right? So given this thing here, they just take the $10,000 times the probability. They don't have to subtract anything. They just take the 10,000 times the probability, which is 10,000 times 0.0015. That will give you negative $15. And you take negative $15 plus the amount of you gain will be, the amount of you gain is the 100, or the common gain is 100, which is, everybody see that regardless of how you do it, you still get $85. The common still gain $85. Okay. So again, you say, this is a little bit easier, which is the only number they give us is the 10,000, the 0.0015, and the 100. We just attack with whatever information they give us, which is, this is what we have. Okay. So let's attack this problem here. I know you say, wait a minute, Mr. Tran, this problem is nothing like the one I showed you in the beginning of class. But again, let's take a look at this problem here, which is this one here is similar or very close to the one that we saw in the beginning of class, right? So again, this one here, they say the game, they changing the story on you guys, they changing the number, but this is what they have is a game is played using one dice. If the dice is rolled and show number 3, the player will win $8. If the dice show a number 3, the player will win $4. If the dice show any other number, the player will win nothing. If there are a $3 chart to play, determine what is the player expected win and expected loss. Okay. So if you attack this problem the way Alex attacked it, this is what you need to ask yourself is, how much will you win? You as a player, how much do you win? Well, you can win $8 and you can win $4. Everybody see that? I can win either $8 or I can win $4, right? So again, this is what I can win. I can win 8 and I can win 4. If I lose, I will lose the $3, right? So if you attack the way Alex attacked, this is what they tell you is take the $8. What is the probability? What is the probability of you winning that $8? Well, the probability of me winning that $8 is 1 out of 6. Why 1? Because the dice have only one side contain number 2. That's why I have 1 out of 6. What's the probability of me winning this $4? Same thing, 1 out of 6. Why? Because there's only one number 3 out of 6-sided. What is the probability of me losing? Well, we don't care about the probability of losing. They give us the probability of winning. We put in the probability of winning, and we subtract what we lost, right? Which is, in this case, this is what you have, which is if you take 8 times 1/6, you get 1.333333. And if you take 4 times 1/6, you get 0.67. And once you add this together, which is again 1.33 plus 0.67, that will give you 2. And 2 minus 3, that will give you a negative 1. So again, in terms of this thing here, the player expected to lose $1 for every time they play. Okay, so on the problem that you showed me earlier, I think they have like number 1, if they can win $2 or win $3 or win $4 or something like that. So again, you just take the amount times the probability and minus what the chart is. What is the cost of the item? okay? Or in terms of number 21, what is the gain of the item, which is 100.